Hello. So we have built a system through the line interface. It is actually a complex model and scientific system like this, but instead of building a interface, we decided, as per our contract, to build a conversational base. So if we want to understand how the models work, where did the data contribute to, and how the climate predictors function, you can simply ask it. For example, you can ask where the predictors and what the predictors are and where they come from, and then you will kill you some information on that. In reporting, I have found that it is quite difficult to outline what's not seen. For example, if you do a variety contract, you can see the different variety in plants, or you can build complicated database like this with interface system like the expert system like this, or you purchase some lab instruments that you can just see the machine. But how do you see an AI? It is something that, in terms of reporting, we have found it quite difficult to communicate because underneath that is just lines and pages of codes, thousands of that. So the important thing to understand is that it is all built behind this interface, this line. So you can just ask it, for example, as something like this, and then it will produce something also including explaining the yield forecast model for different regions, for farm level or for provincial level, for example. In terms of the model building, we took into account the climate factors, and by that, it also means various time lag process, including the development phase of the climate system across the globe, also the growing system of cassava. We use something called a reanalysis. I have introduced many times to the company. This is just an example to demonstrate how reliable the reanalysis data is. This is the reanalysis data comparing with the station data, the rain gauge from Chayapong. Now you can see that even though there is some difference in the peak season, overall they agree well. You can see the correlation here. It doesn't replace the station, but anywhere outside the station, this reanalysis data give you a good approximation. That includes soil moisture, which is not monitored or even measured anywhere around your farms either. So the soil moisture data we did was produced by this ERA5. It is a model derived. What it said derived, it means it also came from observation. So you feed the observational data, the weather data, into this model, and then it produces something through the water balance physics. For example, precipitation through infiltration, and then soil storage and surface evaporation, evapotranspiration, drainage. It's all through the model part. And then it also tightly connects to the precipitation change with the time lag. So this is how the soil moisture data was produced. It can depict the wet-dry cycles. It cannot, of course, replace measurement if you have one. So you can easily ask what the data source are in the AI system. For example, show me how the data source come from. Then you tell you all the data source, including this EIA5 land data. So in terms of the model building, we took steps. The reason is that cassava yield data come from different sources. They are national source, and they are government source. They are provincial sources and also the farm level based. So for the national and provincial data, as we report in this peer review article, we build models like this. First of all is a climate diagnostic analysis. This is an important step because you want to establish the importance and the connections of cassava with the climate variables. After that is done, then we have enough scientific background to build models, and that's what's reported in this paper. So the reason we do the paper is because peer review is by far still the accepted and robust evaluation system, validations basically, so we can let the community to evaluate how validated our models are. Basically, we use different machine learning models and pick the best one through evaluations like this, which is all explained in the paper. And then we try to apply it to provincial or even farm level data points. When you change the input data, you have to change the model. So you can ask the AI, you can ask the line to show you all the different models we use here. Then you will explain all the different things. Because the line system, the line interface does not produce or show equations, mathematical equations, it will give you something more like this type. Okay, but you can see that if you have like a ChatGPT interface, you can see the mathematical equation, including something that we currently use, which is the random forest algorithm. In the model, it will be validated against observation, historical data, and here are some statistics just to show you the variance explained, which is over 50%. Then we can use a different suite of models, including decision tree sometimes, and even simpler linear regression or lag regression models if the signal is strong to capture different level of found data. For localized yield modeling, and you can also ask the AI, for example, for Chayapong, then you will execute the model in different ways, even pick up the different models we have trained, because the input data is different lengths, different behaviors. For example, this is the SQS farmer yield dataset. Now you can see that for the 8 years that the record spent, there's a range of realizations each year. Some spread is bigger, some spread is small. So we first of all have to model the average, and then we have to also take into account the difference, also the challenge of different farm data in different year, because then the time series is not really sequential. Only about half of the farms produce sequential uninterrupted data set. So we try to factor in the signal. So during those high signal years, then we identify the different climate conditions and put more weight on that. These are some provincial data. For example, for AMFA, this is the different level of data we use. And again, we're trying to depict the signal years, and then highlight or put more weights on the climate factors on that. So the models have different weights. So the AMFA data will be different from the Chayapong data. And different farms will have different weighting. And you can ask all that in the AI, in Kuji, for example, as of this date at the location, then you can estimate the yield, and you tell you the percentage of that. And if the more you provide, for example, if you give it like last year's mean yield, then you will give you more trustworthy absolute yield predictions and outlook, but always with a range. You can see that it also give you farming advice like this. It gives you a range and how you can interpret the range or uncertainty. And here are just some more of the demonstration to show you that you can just tell it the name of the place, and you approximate it to the longitude coordinate. Of course, then you can correct it. Say, no, my location is such and such. Then you will fine-tune that. So for the data, let me go through this part. As I said before, you can see that for Chayapong, of the 8 years, only a few years shows you the signal. Some years, which means climatologically normal years, each farm behaves differently. So this would be the noisy years. These will be the signal years. So we put more weight on the signal because we believe that if you want to use climate to forecast it, it's only for the climate conditions that are prone to drought or some extreme conditions that should be forecasted. So here are all the different conditions that you can apply. For example, if you say my farm is at this location, how do you predict the yield? Of course, this is very vague. Normally the question would be more detailed or incrementally with more information. And then you can see that if you give it a planted date, then you will start to calculate all the things according to how long you have planted, and then factor in all the soil type, irrigation type, and then the climate conditions and the climate forecast, the yield forecast into that location. So sometimes with the newer data set, with the newer data coming, the model will have to adjust itself. And we try to automate that as much as possible by retraining all those data. For example, at the end of this year, when the new yield data come in, then you essentially have one more realization per time series, and the signal will change, the model will change, then we have to retrain that. So things will integrate, it will get better and better. In terms of the infrastructure, under the hood, this is what it looks like. Okay, this is all the coding performed by BOM, and you can see this is how the Python code would be engaged into plotting, extracting, analyzing soil moisture data. Then this is how we put into the manuscript with all the correlation analysis, including provincial analysis, like this. The model in our system, the Kuji system, integrates all this climate forecast information around the globe. These are the weather services, either from cross-governmental agencies like the APEC Center, like the European Union, also from individual countries like the US, like Japan, and then we put them all together. You will update the information weekly, at least monthly, because these are the seasonal forecast data, and they don't update every day. But every time you ask Kuji about the climate and yield relationship, you will have already know the latest information. But forecasts change. So if you ask this month and you'd ask again next month, the result will be slightly different. But then you get the state of the art information from climate. Behind the hood, under the hood, all this climate forecast look like this, very complicated. No one really understands it. But through AI and through our models, it will automatically translate this information into your outlook. And of course, we have the satellite-derived soil moisture as well. You can ask it, and Kuji will tell you that you use some NASA data. Also this gravity-derived soil moisture data as a monitoring reference. Okay, and then you can ask all kind of questions. You can ask the planting time frame. For example, if you want to plant in certain time, it will tell you that maybe in this week is proper or improper, and then you can ask it to narrow it down to the week or to narrow it down to even dates. So this is the architecture of the AI. Everything that we've been built, this is what the project really is about, is this part. The vector database, vector means directional. It means whatever AI interface we use. Currently we use ChatGPT. So ChatGPT, after understanding your question, you come in here and get all the information with all the model input and output, and then feedback, and use the GPT again to reason and to reply you. Then it fits to the line interface as a conversational things. It limits the display of some complicated data or image, but it streamlines the communication process. So we believe that through ingesting farmer input, we can also help them understand their options. Essentially, it's like pushing or promoting an AI chatbot, or more specifically, the AI agronomist to all the farmers, including their financial options as well. And here is a very quick demo of how I believe and why I believe this can work. This is a former paper that I did when I was in Utah. We used the Twitter data, basically charts, right, social medias, to predict drought. Long story short, we use a lot of manpower to sort through all these texting messages, and including pick up the keywords like this, and then eventually the result is that it works. But the more important thing is what was a very heavy manual process, man labor intense process of cleaning the data. Today we can simply use the GPT system or the LLM here to do it in a very quick manner. Therefore, it can be done real time, that you can dissect all the information and then give prediction like this vector analysis to point to the direction. So the more farmers who use this line to communicate, to also provide information, the more likely it can help you predict the yield as well, just by sharing the information. So it is catch-22, right? In the beginning, few people use it, and maybe there's not much of the function, but the more people use it, the better the function will be. And I hope we can work together on that. And in the end, I do want to say that in the beginning, we did incorporate the G-star data, but as you can see, the G-star planted area, they change it every 2 weeks. So unless SMS can tell me which data point to use, for example, we can pick up the largest area, then otherwise, if we use this G-star, then the planted area will change and become inaccurate. So right now we are only using the governmental data, but it is 1 year old, as you know. So we will have to refine on that, or maybe it's worth discussing. So if you ask the AI, it will tell you how we treat the G-star data here. They will tell you why this is currently not being used, even though we did factor this information. Okay, so that's the update for our project here concerning the Kuji AI. Thank you very much.